it is permissible to use 250 MCM URD underground residential distribution cable in parallel installations despite having a derated neutral, provided certain conditions are met according to the National Electrical Code, or NEC. The key considerations revolve around the neutral conductor's function and capacity within the parallel setup. The NEC allows the use of 250 MCM URD in parallel applications if firstly, the neutral conductor does not carry more than 50% of the total load current, and secondly, the neutral conductor is adequately sized to handle the full load current of the largest branch circuit or feeder it serves. In a scenario where two 80-foot sections of 250 MCM URD are intended for a parallel service, this is acceptable provided that the neutral conductor is capable of carrying the service's total load current. The derated neutral in 250 MCM URD arises because the neutral conductor is constructed from aluminum, whereas the phase conductors are copper. Aluminum exhibits higher electrical resistance compared to copper, making it less effective at conducting electricity. Consequently, the neutral conductor in 250 MCM URD is rated to handle only 50% of the current that the phase conductors are designed to carry. However, the principle of parallel installations involves an even distribution of current between the parallel conductors. Each conductor carries only 50% of the total load current. This falls within the neutral conductor's rated capacity. It is very important to adhere to the National Electrical Code (NEC) standards when installing electrical systems. These standards ensure safety and compliance. When dealing with parallel installations using URD cables, it is critical to verify that the neutral conductor is appropriately sized to manage the load it will be subjected to. Failure to do so can result in overheating, insulation failure, and potential electrical hazards. Always consult the latest edition of the NEC and seek guidance from qualified electrical engineers or inspectors to ensure compliance with all applicable regulations and safety standards. The proper installation of electrical systems is paramount for preventing electrical fires and ensuring the safety of individuals and property. When planning to use 250 MCM URD in parallel, it is important to first calculate the total load the service will need to handle. Once the total load is known, you can determine the appropriate size of the conductors and the neutral conductor. In a parallel installation, the current is divided between the conductors, so each conductor will carry only a portion of the total load. However, it is important to ensure that each conductor is sized to handle its share of the load, as well as any potential overload conditions. The NEC provides tables and guidelines for determining the appropriate size of conductors for different applications. These tables take into account the ampacity of the conductor, the ambient temperature, and other factors that can affect the conductor's ability to carry current safely. When sizing the neutral conductor, it is important to consider the type of load that it will be serving. If the load is primarily nonlinear, such as with electronic devices, the neutral conductor may need to be oversized to handle the harmonic currents that can be generated. The NEC provides specific requirements for sizing neutral conductors in these types of applications. In addition to conductor sizing, it is also important to consider the installation methods used when running URD cable in parallel. The NEC specifies requirements for how conductors must be supported, protected, and terminated. These requirements are designed to prevent damage to the conductors and ensure that they are properly connected to the electrical system. One important consideration is the use of proper connectors. When connecting conductors in parallel, it is important to use connectors that are specifically designed for this purpose. These connectors will ensure a secure and reliable connection between the conductors, which is essential for safe and efficient operation of the electrical system. Another important consideration is the routing of the conductors. When running conductors in parallel, it is important to ensure that they are routed in a way that minimizes the risk of damage or interference. The NEC provides guidelines for the spacing and separation of conductors, as well as for protecting them from physical damage. Finally, it is important to thoroughly inspect the completed installation to ensure that it meets all applicable code requirements. This inspection should include a visual examination of the conductors, connectors, and other components, as well as electrical testing to verify that the system is operating properly. By following these guidelines, you can ensure that 250 MCM URD cable is safely and effectively used in parallel installations. Remember to always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working with electrical systems. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. When working with URD cables in parallel, it's essential to consult the NEC for specific requirements. Firstly, the NEC addresses conductor ampacity. It provides tables like NEC Table 310.15b16, which lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in accordance with the temperature rating of the terminations. These tables help determine the appropriate conductor size based on the load and ambient temperature. Secondly, the NEC covers parallel installations. Section 310.10h outlines the requirements for conductors connected in parallel. This section specifies that conductors must be the same length, conductor material, circular mill area, and have the same insulation type. The termination of parallel conductors also needs to be done in the same manner. Thirdly, the NEC details neutral conductor sizing. Section 220.61 provides guidance on sizing the neutral conductor for various types of loads. It specifies that the neutral conductor must be sized to carry the maximum unbalanced load. In some cases, the neutral conductor may need to be larger than the phase conductors. Fourthly, the NEC discusses derating factors. Article 310 addresses derating factors for conductors in raceways or cables. When multiple conductors are installed in close proximity, their ampacity may need to be derated to prevent overheating. NEC provides tables to determine the appropriate derating factors based on the number of conductors and the ambient temperature. Fifthly, the NEC addresses grounding and bonding. Article 250 provides requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for safety and to prevent electrical shock hazards. It is important to ensure that all metal parts of the electrical system are properly grounded and bonded. Sixthly, the NEC discusses overcurrent protection. Article 240 provides requirements for overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect the electrical system from overloads and short circuits. It is important to select the appropriate overcurrent protection device for the conductor size and the load it will be serving. Seventhly, the NEC covers wiring methods. Chapter 3 provides requirements for various wiring methods, such as conduit, cable trays, and direct burial. The selection of the appropriate wiring method depends on the application and the environment. It is important to follow the NEC requirements for the selected wiring method to ensure a safe and reliable installation. Eighthly, the NEC addresses equipment listing and labeling. Article 110 provides requirements for equipment listing and labeling. All electrical equipment must be listed by a recognized testing laboratory and labeled with the appropriate ratings. This ensures that the equipment has been tested and meets safety standards. Ninthly, the NEC discusses voltage drop. Informative Annex C provides guidelines for calculating voltage drop in electrical circuits. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. It is important to size conductors to minimize voltage drop. Tenthly, the NEC covers emergency systems. Article 700 provides requirements for emergency systems, such as emergency lighting and standby power systems. These systems are designed to provide power and lighting in the event of a power outage. It is important to follow the NEC requirements for emergency systems to ensure that they will function properly when needed. Remember to always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working with electrical systems. The NEC is a complex document, and it is important to have a thorough understanding of its requirements to ensure a safe and compliant installation. When working with parallel installations of URD cable, it's vital to understand how current is distributed among the conductors. In a properly installed parallel system, the current should divide equally between the conductors. However, Several factors can affect current distribution, including conductor length, impedance, and termination methods. Unequal current distribution can lead to overheating and premature failure of one or more conductors. It's crucial to ensure that all conductors are of equal length and have the same impedance. This can be achieved by using conductors from the same manufacturer and production lot. Additionally, proper termination methods are essential for ensuring equal current distribution. Terminations should be clean, tight, and made with the appropriate connectors. Loose or corroded terminations can increase impedance and cause unequal current distribution. Regular inspection and maintenance of parallel conductor systems are essential for identifying and correcting any issues that may arise. This includes checking for loose connections, corrosion, and any signs of overheating. Thermographic scanning can be used to identify hotspots, which may indicate unequal current distribution or other problems. If unequal current distribution is detected, it's important to take corrective action immediately. This may involve tightening connections, replacing corroded components, or reconfiguring the parallel conductors. In some cases, it may be necessary to replace the entire parallel conductor system to ensure safe and reliable operation. Remember to always follow the manufacturer's recommendations and the NEC requirements when installing and maintaining parallel conductor systems. And do not forget to consult with qualified electrical professionals for assistance with complex installations or troubleshooting. Ensuring proper current distribution in parallel conductor systems is essential for safety, reliability, and efficiency. By understanding the factors that affect current distribution and implementing appropriate maintenance practices, you can help to prevent problems and extend the life of your electrical system. Let's delve deeper into the specific requirements for parallel installations as outlined in the NEC. Firstly, conductor size is a critical factor. According to NEC Section 310.10, hone conductors size 1/0 AWG American wire gauge and larger are permitted to be run in parallel. This requirement ensures that the conductors are of sufficient size to handle the load current safely and efficiently. Secondly, conductor characteristics must be considered. The NEC states that all parallel conductors must have the same electrical characteristics. This means that they must be made of the same material, have the same cross-sectional area, have the same insulation type, and be terminated in the same manner. This requirement ensures that the current is distributed equally among the parallel conductors. Thirdly, overcurrent protection is essential. Each parallel conductor must be protected by an individual overcurrent device, such as a circuit breaker or fuse. This protects the conductors from overloads and short circuits. The overcurrent devices must be sized appropriately for the conductor ampacity and the load current. Fourthly, grouping of conductors is important. The NEC requires that all parallel conductors be grouped together in the same raceway or cable tray. This helps to ensure that the conductors are exposed to the same ambient temperature and that the current is distributed equally among them. Fifthly, termination methods must be consistent. All parallel conductors must be terminated in the same manner. This means using the same type of connectors, applying the same torque, and following the manufacturer's instructions. Inconsistent termination methods can lead to unequal current distribution and overheating. Sixthly, conductor length should be equalized. The NEC recommends that all parallel conductors be of the same length. This helps to ensure that the impedance of each conductor is the same, which promotes equal current distribution. Seventhly, marking of conductors is necessary. The NEC requires that all parallel conductors be marked to identify them as part of the same circuit. This helps to prevent confusion and ensures that the conductors are properly connected. Eighthly, accessible locations are important. The NEC requires that all parallel conductors be accessible for inspection and maintenance. This allows electricians to easily check the connections, terminations, and overall condition of the conductors. Ninthly, bonding and grounding are essential. The NEC requires that all parallel conductors be properly bonded and grounded. This helps to prevent electrical shock hazards and ensures that the electrical system is safe. Tenthly, professional installation is recommended. Parallel installations can be complex and require specialized knowledge and skills. It is always best to have a qualified electrician perform the installation to ensure that it is done safely and in accordance with the NEC. By following these requirements and guidelines, you can ensure that parallel installations are safe, reliable, and efficient. Remember to always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working with electrical systems.